Welcome everybody. In this video, I will explain how to visualize geospatial data. So I will first import Folium, GeoPandas, and Pandas, and then read my data. So data has ship extension. So and it takes some time because it's a quite big data file. So let's just check how data frame looks like. And then yeah, we have like weird numbers like in Polygon because we have different projections. So we have to change the projection to VSG 84. So this projection gives us real coordinates on the Earth. So we use like we can use this code and which specifies the projection to this format, and then I run it, and it takes some time because yes, it just checks all these polygons and change them to uh, coordinates yes, coordinates like longitude and latitude. So what I have to do next, so these are polygons, like polygons are regions, and this if every region has few longitude and latitude um, because like this longitude and latitude coordinates are borders or limits of the region. So what we have to find the like centroid of each polygon. So once we have centroids, and then we can find distances between those centroids and my home address. So for centroid, I just use like this code, and you can check this notebook in the description. I will leave the link in the description. So I create a new column, a longitude, and just like it takes a longitude of centroid, and this like second new column is the latitude of the centroid. So let's run them and check our data frame again. So how it looks like, yeah, it looks like this. I have two more columns. So what I have to do, I just want to keep uh, columns I will need. So I just take the first one. This is identifier. And of course, I take the column, two last two columns like coordinates, so longitude, yes, and I take latitude, of course, and I give the results to my data frame. I save it, check again. Yes. So next, I want to visualize statistical sectors within a 2 kilometer radius of my home using Haversine function. So for this, let's first create a simple map, simple interactive map to show the Belgium, let's say. So I already have a coordinates of Belgium. I just like save them. I give these numbers to the variables, and I create a simple map, interactive map to see like the Belgium as a country, then we will later plot statistical sectors on the map. So I just use a Folium map for this purpose, and I create map Belgium, Folium map. I have to specify location, and I have already location here, so I just take this latitude and longitude. And here I specify start zone. Maybe eight. Eight is okay. Eight is good. It's big enough. And I just pull out the visualize the map. So we already have interactive map. Let's a little bit zoom out. Yes, this is Belgium. Um, and then I just like next want to visualize like all statistical points, but I have like more than 20,000 statistical sectors, statistical units. Therefore, it will take a lot of time to visualize all these units on one map. Therefore, I just want to take like 40 rows and visualize them first, and to check how statistical sectors on the map look like. So here I've already like specified the code. I just like took a 40, and here I have a for loop, and this for loop checks columns, like each column, like this is a unique number, and this is a latitude and longitude of each centroid, and it gives the result to a pop-up function, and then this is a function from Folium. It's called circle marker. It just takes location and some color function. It has some features, and then it creates units on the map. So let's run this and let's check how statistical units look like on the map. Then yes, we already have all statistical points. Like map was a little bit zoomed in. So here we can specify the color. Here I want to make it blue, and opacity values like near 1 mean the filling is darker. So I just specified to 1 to have very dark filling, and yes, we have that already. It's dark blue. And next is a Haversine function, because the purpose of this like notebook of this video is to create Haversine function. So for Haversine function, if you can search and we can easily find the function, but we will modify it a bit. And here's a function. I have already found it. So we will use the same function, but of course I will make some modifications here. This function takes 4 values, but I don't want 4 values. I just want to give one data frame to the function. That's why I just like write one letter like K, which represents my data frame, and therefore here I specify a data frame column longitude. Here this is latitude, and this is my home address, home longitude, and this is my home latitude. So I copy paste all these values into here, and then here I'll still have to specify this is home longitude minus longitude of the centroid, and here is same latitude, home latitude, and here latitude of the centroid, and same here. This is the latitude of the centroid here, and here latitude home latitude. I just want to modify this like end of this function here. Yes, it takes this number is radius of the earth in kilometers, so I just create kilometer variable and multiply this number by c. I don't need r. So result like function will return kilometers. So it will return me results distances in kilometers. So let's specify. Let's run this this code, and then I will specify. I already have my home address here. I will create 2 columns in my data frame, which will take coordinates of my home. Let's run them. And next, first, I mean, we can already check how it looks like. The data frame looks like. Yes, I have 2 more columns, like my home coordinates. So now next, I have to, of course, I have to use the Haversine function. And how I do this, I create a new column. It's called distance, and it will take the result of Haversine function. So I will use apply Haversine access one. So as you see, I don't use any value, any input for Haversine because Haversine only takes one data frame and I already have data frame over here. So that's why I modified this function a bit. So we can already run this and then let's check how it looks like. And then we have distance, like take some time. Yes, we have distances between my home and centroid. So I just want to specify distances, like places as neighborhood if they are closer than 2 kilometers. So that therefore here I write my data frame. I'm using lock. So then data frame distance, and if distance is smaller than 2, I will call it my neighborhood. Yeah. And yeah, it's 1. So my neighborhood is 1. If distance is bigger than 2, then my neighborhood column will be 0. So let's check it. Yeah, these are so far, for example, 36 kilometer, 50, 46 kilometer, 41, and they cannot be in my neighborhood. So what I do next, I only keep, I create a new data frame and keep the places which are in my neighborhood. So I create a new data frame and I call it neighborhood. And this only takes values which are in my neighborhood. So I just specify if neighborhood uh, equals to 1, then keep it. Yes, I give it to this new data frame, and yes, we can check how it looks like. Head. Yeah, perfect. So here next I will just like plot all statistical sector centroids in my neighborhood. So what I do, I just like plot them and add them to my neighborhood the map. So here I think I have to create a new map which is my neighborhood, and I just copy paste the same code, but I just change it to neighborhood because I have different map here. So I call it a map neighborhood and see map neighborhood. And here I have 2 different values for my neighborhood. So let's check them first. Yeah, my latitude 51. Yeah, this is my latitude, and the longitude of my neighborhood is 442.771. And here, yeah, it just takes a latitude and a longitude. And yes, this is my neighborhood, and it's like so far, but still, this is the neighborhood. And next, I want to plot all the statistical sectors in my neighborhood. And I take the same code here. I just take the same code because I need the same code, but I will slightly modify it later on. Yes, here I take the same one. The only difference is here I have to specify the name of my data frame, which is yes, GDF data frame. I specify yes, and I add the results to map neighborhood. Yeah, now it should work. So here I have all statistical sectors in my neighborhood. So let's say statistical sectors which are in a 2 kilometer radius of my home address. So what I do next, I have the last step. I take the same map, same code, but I add my home address. So in as red marker. Uh, Only thing I change here is the column. So here I used longitude, my home. Yes, it's longitude on my home. And this is latitude home. Everything is the same, but I just change the color to red. To red. Yeah, now it should work. Yes, perfect. Yeah, it's already, yeah. So what I have here, I first just took all statistical points like throughout throughout the country, Belgium, but then I chose like statistical sectors which are in my neighborhood, like put differently, which are in a 2 kilometer radius of my home address, and then I plotted them in blue, and also plotted my home address in red, and this is how it looks like. So thanks for watching the video, and see you soon.